is on the basics of nonparametric tests. And a nonparametric test, the parametric versions, so the parametric tests, they have requirements about the distribution of the populations involved. And a nonparametric test, which can also be referred to as a distribution-free test, does not require that the samples come from populations with normal distributions, or any other particular distributions about that. Some tests involve a parameter, such as the median, but for the most part, though, these are more relaxed, not as strict. So the parametric tests themselves are pretty strict, for the most part, in terms of the distribution involved. The nonparametric tests, though, are not as strict, and oftentimes don't require any type of, or any distributions whatsoever, which is nice. The advantage to a nonparametric test is because nonparametric tests have less rigid requirements than parametric tests. They can be applied to a wider variety of situations. And nonparametric tests can be applied to more data types than parametric tests, such as ranks and categorical data. Disadvantages, though, are that the nonparametric tests tend to waste information because exact numerical data are often reduced to a qualitative form, and nonparametric tests are not as efficient as parametric tests. So a nonparametric test generally needs stronger evidence to reject the null hypothesis, such as a larger sample, a greater difference, that type of thing. And the efficiency of a nonparametric test is that since parametric tests have higher efficiency ratings than their nonparametric counterparts, it is generally better to use parametric tests when their required assumptions are satisfied. It should be noted that there are times when the nonparametric counterpart has an efficiency rating that's pretty good, which is why sometimes that might even be more preferable, depending on the situation. The rank, though, is defined as a number assigned to an individual sample item according to its order in a sorted list. And if there is a tie, we assign the mean rank to each of the tied items. So for matched pairs of sample data, we can use the t-test for the parametric test. But the non-parametric test versions, we have two types here. We can use the sign test, which is the very basic of tests. That has an efficiency rating of 0.63, so it is typically not used that often due to that limitation. Or the Wilcoxon signed ranks test. That one is a vast improvement over the sign test, and it has an efficiency rating of 0.95, which makes it pretty usable. The two independent samples, we could use again a t-test for the parametric test, or for the non-parametric test, the Wilcoxon rank sum test. Again, that has an efficiency rating of 0.95. That one's pretty good too. For three or more independent samples, we could use the ANOVA, analysis of variance f-test. Or the non-parametric test would be the Kruskal-Wallis test. That has an efficiency rating of 0.95. Also pretty good. And then finally the correlation. That parametric test is linear correlation coefficient. And the non-parametric test is the rank correlation test. That one has an efficiency rating of 0.91. So that one's not as... Whoopsie daisy. That is not as efficient as the previous three tests, unfortunately. But it's also not the most inefficient, like the sign test, for example. For example, just to look at the idea of ranks, the numbers 4, 5, 5, 5, 10, 11, and 12 are given ranks of 1, 3, 3, 3, 5, 6, 7.5, and 7.5 respectively. This table illustrates the procedure for handling the ties. So 4 is the smallest, that's given a rank of 1. 5 is listed 3 times. And because of that, within the fact that we have these three, that would be, these fives would be split between rankings of 2, 3, and 4. Because they're all the same number, we're going to average those to a value of 3. So each of these fives will have a rank of 3. 10 is the next number, that then has a rank of 5. 11 is the next after that, that has a rank of 6. And then 12 was to twice, would have rankings 7 and 8. Average those, you get 7.5 for those two rankings. Let me know if you have any questions or concerns. Thank you.